Hello friends. In the last lecture, uh, there were some questions for comparing the bond angles, and now we solve these questions. The question was that we are to compare bond angles and we are to arrange them in increasing order of bond angles. These are the questions. So first question is OSF2, OSCl2, OSBr2. So here the bond angle is 92.3 and 96.2 and then 98.2. So the correct order is OSF2. This is the increasing order, and the main principle is that it is based on atomic size of the bonded atom and as well as electronegativity of bonded atom. So on the basis of both of these rules, we get this solution. See, atomic size, according to atomic size, fluorine is less than chlorine and chlorine is less than bromine. And according to electronegativity, fluorine is more than chlorine, chlorine is more than bromine. So in both the cases, if size is less, then bond angle will be less. So according to atomic size, this trend is applicable, and according to electronegativity also, this trend is justified. Now we come to this question, H2O, H2S. Here the correct solution is H2TE less than H2SE less than H2S is less than H2O. Here it is 90.2 degree, here 90.6, then 92.1 and 104.5. So the principle is again atomic size and electronegativity. By both ways we get this trend in the bond angle of these molecules. And third question is, these three molecules, they are all having sp3. This is sp3 hybridization, this is sp2, and this is sp. So as the hybridization S character decreases, the bond angle also decreases. So this is 180 degree, this is 120 degree, and this is 109.5. So if we place them in increasing order, then this is the trend. This is hybridization principle. Now the fourth question is, these four molecules, we see that there is trend that this bond angle is less than, this is the trend, and this is according to electronegativity of bonded atom. Okay, this is the principle, because if we arrange them in the bonded atom according to electronegativity, then F has the maximum electronegativity, then chlorine, then bromine, and then iodine. So according to this is the trend. Now In this lesson, we are going to do one more topic, and that is bond order. What is bond order? First, let us define what is a bond order. Bond order is this bond is, there are number of bonds is 1, so we say that bond order is equal to 1. And if number of bonds is 2, then we say bond order is 2. If number of bonds 3, then we say bond order is equal to 3. But in more complicated molecules, the calculation of bond order is not so easy. So we have got a simple trick to calculate bond order of a molecule. See, we write number of electrons. If 14 is the number of the molecule, if 14 is the number of electron shell, then if 14 is the number of electrons, then bond order is 3. Then 13, 12, and we decrease this bond order by 0.5. It is 2.5. Then for 12 number of electrons, it is 2. For 11, it is 1.5. And again for 10, we decrease it by 0.5 and it becomes 1. And for 9, it is 0.5. And for 8, this is 0. And again, if number of electrons is more than 14, then we again prepare a table. For 14, it is 3. And for 15, we will decrease it by 0.5 and it will become 2.5. For 16, it will be 2. For 17, it will be 1.5. For 18, it will be 1. And for 19, it will be 0. So this is the simple trick for number of electrons 8 to 20. But if we have number of electrons from 1 to 7, then what will be the position? We shall arrange those electrons in these orbitals. These are bonding orbital, this is anti-bonding orbital, this is bonding orbital, this is anti-bonding orbital. And then we shall calculate 2 electrons each in one orbital. Then we shall calculate bond order by this formula, Nb minus Na divided by 2, where Nb is the number of electrons in bonding orbitals and Na is the number of electrons in anti-bonding orbitals. So we shall calculate bond order in the later part of this video. First, we see that what is bond order significance. See, bond enthalpy or bond dissociation energy is directly proportional to bond order. Higher the bond order, bond enthalpy will be more, and bond strength is directly proportional to bond order. Okay, and again, stability of molecule is directly proportional to bond order. But bond length, it is inversely related to bond order. So these are the 4 relations, and if we are asked any of these properties of given molecules, then we can calculate bond order, and according to the order of the bond order of those molecules, we can determine the order of these properties. Now we come on to the calculation of the bond order. Let us first calculate the bond order of Cn plus. See, we are to calculate number of electrons. C has electrons 6 plus n has 7, and for plus there is minus 1 electron, and this comes to be 6 plus 7 13 minus 1 12, and for 12 we have bond order. See, in this table we have bond order 2, so this has bond order is equal to 2. Cn minus C6 and 7, and for minus charge 1 electron is added, and this becomes 6 plus 7 13 plus 1 14. For 14 in the table we see that bond order is 3. So here the bond order is 3. Now NO, N7, oxygen 8, we get 15, and for 15 we have bond order 2.5. So bond order is 2.5. And Cn 6 plus 7 is equal to 13, and bond order is equal to, for 13 the bond order is 2.5, and this is 2.5. This way we can calculate the bond order. Again we can calculate O2, 8 plus 8, number of electrons 8 plus 8 is equal to 16, and corresponding to 16 the bond order is 2. Here bond order is 2. Here O2 plus 8 minus 1. For plus charge minus 1 is taken. 16 minus 1 15, and for 15 again we can refer the table, and for 15 this is 2.5. Bond order is 2.5. O2 minus 8 plus 8, and for minus plus 1 electron is added, plus this becomes 17, and for 17 the bond order is 1.5. Again in this 8 plus 8, for 2 minus we add 2 electrons and it becomes 18, and for 18 we refer to the table, for 18 this is 1, bond order is 1. This way we can calculate the bond order. Now if we arrange them in increasing order of the bond order, or we arrange them in the increasing order of the bond order, then we say that bond order minimum is 2, and let us arrange this in increasing order. This is the least, then this, and then this. So O2 2 minus bond order, and this O2 minus, then O2, and then O2 2 plus. This is the increasing bond order, and we have seen that bond enthalpy, bond strength, and stability of the molecule, they are all directly related to bond order. So it is also the trend of increasing bond order and increasing bond strength, and also the trend of increasing bond or molecule stability. But bond length is inversely proportional, inverse to bond order. Then we say that this is decreasing order of bond length. Okay. Now we calculate bond order of He2. See, He2 is equal to number of electrons is equal to 2 plus 2 is equal to 4. Okay. Now we cannot have refer to the table, but we can refer to this formula where we can arrange 4 electrons, here 2 electrons and here 2 electrons. 2 electrons at the most can be accommodated by one orbital. So bond order see, bond order of He2 will be number of electrons in bonding molecule. In bonding it is 2. This is bonding molecule, it is 2, and for anti-bonding it is 2. Minus 2 divided by 2. Bond order of He2 is 0 by 2, which is 0. When bond order of any molecule is 0, the molecule does not exist. Okay, so we say that He2 does not exist because its bond order is 0. Now I give you some of the questions to solve, and we shall see the solution of these questions in our next video. Please write the solutions of these questions in the comment box, and then we will see that what is the status of your solution in our next video. Thank you for watching the